Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this episode what we're going to be talking about are solving and graphing inequalities in algebra. This is for Algebra 1 students. But before we begin, in the previous video we laid all the groundwork so students can understand all of this right here. So we have strict inequalities, less than, greater than, those get an open circle, which means that the number is not included, and we have not strict inequalities. I think people actually call them lenient, which I think is kind of funny, and that is that they could be equal, so we use a solid dot for that, and that means that the number that has a solid dot on it could be an answer. Now, here's what it looks like on a graph. Where your line goes or where you shade, that's where your answers are. Where it's blank, there's no answers. Yeah? Now, what we're going to learn today is we're going to learn that we're using inverse operations to solve, and then there's a slight variation on inverse operations that we're going to learn about. So, here we go. What is this a picture of? Did you say a number line? I hope so. All right, now, what's this a picture of? Did you say -1? Because that's what that's a picture of. That's all it is. We have a solid dot on -1. That's just it. Now, what we have is a picture of all of the numbers less than -1. Now, if you watched the last video, you probably know that the answer to this question, what's the smallest number graphed here, is, well, that there isn't one. Because numbers go to the left on the number line forever. They get smaller and smaller. Now, if you watched the last video, you probably also know that the largest number graphed here on this graph in particular is -1 because it has a solid dot on it, and that means that the number is included. Now, if you didn't watch the other video and some of this is confusing, I'll put a link in the description below. You can go ahead and pause this one, watch that, and you'll be ready to rock. All right, now, could you describe this graph in words? So what this is in words is all numbers less than or equal to -1. Good to go? Now, could you describe this mathematically? Could you write this statement mathematically? I hope so. There's two ways. You could say x is less than or equal to -1, or you could say -1 is greater than or equal to x. You need to be able to do both. Okay. Now, all numbers less than or equal to -1. All numbers less than or equal to -1. So what if we got rid of that? What if we said all numbers less than -1? Could you write that mathematically? Well, there's two answers to that. X is less than -1, or -1 is greater than x. The smallest answer here, well, there still isn't one, because numbers go to the left forever. And the biggest number, well, there isn't one of those either. And the reason why? Well, because the -1 is not included. Now, if we were going to graph it, what we'd do is we'd put an open circle on the -1, and that means the -1's not included, and then all the numbers to the left are an answer to this inequality. So there we go. Now, it might be smarter if we use this symbol, the not symbol, the not allowed symbol, in place of an open circle, but we use an open circle. It means the same thing. Now, what's this a picture of? Did you say x is greater than 2? If you did, you're good to go. All right. What about now? This is a really confusing thing, right? What is the smallest number that's graphed? Well, there isn't one because it goes on forever. What's the biggest number that's graphed? Well, there isn't one of those either. Could you, though, describe this in words? This is tricky. Give it a shot. So what this actually says is this says all numbers that are, well, less than or equal to -1, but also they're greater than 2. That's what this says. Now, if we were going to write that mathematically, we'd have to use an or. So we would say x is less than or equal to -1, or x is greater than 2. So we're going to get into this in greater detail in the future. But for right now, do you see how these two match? We're not going to see any problems in this video where we have to answer these kinds of or. These are called compound inequalities, but you should be able to read them. What's this a picture of? It's kind of hard to say, right? We don't have all the information. We don't know what goes here yet. So, is there a smallest number, though? Absolutely, because we have a solid dot on the -1. Is there a biggest one? Well, it depends on what symbol we put here. So what if we put an open circle? Is there a largest answer? No, of course not, because open circle means the number's not included, right? How could you describe this in words? Well, this is a picture of all the numbers that are more than -1, but they're also less than 2. That's kind of strange, right? Now, if you were going to write that mathematically, all of the numbers that are greater than -1 and that are less than 2. So because you could say x is greater than -1, or you could also say -1 is less than x. You could also say that x is less than 2. You could actually write this whole thing right here in one boom statement right there. How do you like that, huh? Now, let's go ahead and take a look. We've got that a graph is a picture of all solutions, right? And that we have strict inequalities like these right here. And that means if you have an open dot that the number is not included. And then we have not strict inequalities, less than or equal to. And on a graph, we use a solid dot to denote that. So for example, this right here is not a strict inequality. The -1 is included, right? And just to make sure, all answers are where the lines are. Where there's no line or no shading, no answers there, right? Now, we want to make sure if you can graph an inequality and if you could write an inequality from a graph. So let's get to it, right? Let's start with the solving. Now, solving means that we're going to find a solution that makes the value true, right? So how many solutions does this have? Well, that's kind of strange. Well, if you just talk about the integers, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah, you got the idea, right? And that's why we use graphs for these inequalities. So let's try one, right? Now, this is a little trickier than what we did last time. What we're going to use is, we're going to use algebra. Algebra takes the rules of math, which is the order of operations, flips them around. We do it backwards. We find the solution to this equation by doing it backwards. So we need to get the x by itself. That's when we're done solving. And there are two numbers that are keeping us from doing that. We have the 5, which is adding. The opposite of add is subtract. And we have the 4 that's multiplying. Opposite of multiply, divide. So we're going to do those operations in this order. It's the inverse operation. So it's subtract, add, divide, multiply, exponents, and then anything in a group. So let's do it, right? We subtract 5 from both sides. 4x is greater than -6. Now, you don't need a 0. You don't need to write +0. So we're not even going to write that, right? Just 4x. We're going to divide by 4 on both sides, and that's just reducing. But you need to make sure you reduce both sides. So 4 divided by 4 is 1. Don't really need to write the 1, right? So we're just going to write x is greater than -3/2. -1/2 is another way to say that. So let's talk about graphing this, shall we? X is greater than -3/2. -3/2, it's about 1/2. Well, no, it's exactly 1/2. That's going to be between -2 and -1. It's going to be right in the middle. So we're just going to put a circle in the middle. And then greater than, that's to the right. All the numbers that are larger are to the right. So x is greater than -1/2. Now, all of our answers are over here where the line is drawn, and things that aren't answers, that are false, they're not solutions, are where the line is not drawn. So let's try an example. Let's say x is equal to -1. If we plug -1 in, we're going to get something that's true. See? 1 is greater than -1. That's true. Whereas if we take a number that's over here where we don't have our shading and we plug it in, we're going to find out that we get something that's false, like -15 is greater than -1. That doesn't work, right? Now, the order of operations and the inverse operations for solving inequalities, everything's the same except for one situation. Here, no problems. You're going to use the inverse operations that you know and love, right? Same with this, same with this, and same with this. All of these, no problems whatsoever. Now, here though, we got something that's a little different. 6 minus 7 times x is less than 3. So let's take a look at how this works, right? So we have our equation right here, and if we subtract 6 from both sides, we get -7x is less than 3. We divide both sides by -7. Negative divided by a negative is positive, and if you divide or multiply both sides of an inequality by a negative, you have to flip that inequality sign around. Well, that's really weird, right? That's the only difference, though. If you're solving an inequality, you have a negative sign that you have to multiply or divide to get rid of that negative, then you have to change the sign of the inequality. So let's take a look at maybe see why that is. So we could start this same problem with a different method, right? Let's go ahead and add 7x to both sides. Now it's positive. Subtract 3, right? You get 3. Go ahead and divide by 7. Same exact answer. Look, x is larger than 3/7. That's the same as saying 3/7 is less than x, right? Because, you could say both of these statements the same way. You could say I'm taller than you or you're shorter than me. They have the same exact meaning. And so this and this, 100% the same. So the moral of the story is if you multiply or divide an inequality by a negative number, the direction of the inequality has to change. Yeah? All right, so let's put together everything we've got. You should, at this point, know how to solve inequalities by using inverse operations, and you should understand what it means to flip the sign if you multiply or divide by a negative. Now, misconception, people often start to flip the sign if they subtract from both sides, and that's not it. It's only if you multiply or divide. All right, so I'm going to show you some practice problems that I think would be a really great thing to try. I'm going to put some more resources and help for you. I'll put a link in the description below. You can visit my website, thebeardedmathman.com. Lots of great stuff there to help you out through high school level math. If you like this video, give it a thumbs up. It'll help people find it. If you would like to be notified when more videos come out, hey, go ahead and subscribe. So here are the practice problems. Go ahead and give them a shot. I will put a link in the description below so you can get some more help with these if these are confusing or you get stuck. Anyway, I thank you for your time. I hope it's been helpful. If it has, leave me a comment, and, I hope you have a great day.